Okay, today we're going to be talking about angles and angle measures. The first thing that we need to talk about when we're talking about angles are the different parts and what makes up an angle. The primary part of an angle is a ray. A ray is a part of a line that has one endpoint and it extends indefinitely in one direction. So a ray is used to make up an angle um, by forming the sides. The sides are two non-collinear, which means that they're not in a straight line, that have a common endpoint and form an angle. The vertex are where the two rays or the two sides of an angle meet. In this case, the sides are X and Y, and X and Z, and the vertex is X. When you're naming an angle, 3 points are used. And of those 3 points, 2 of them are on the sides, and the third point is the vertex, and the vertex has to be the middle point. When you have an angle that only has one angle associated with a vertex, that angle can be named by only using the vertex point, but that generally is not very common in the work that we're doing. So in this example here, we're asked what are the names of the angles that are shown. So, like I said before, we're going to name it using the 3 points. Okay, so we have a point Y, we have a point X, that's the vertex, and we have a point Z. Okay, so this can be labeled as Y, X, Z, or we could also label it the other way around, Z, X, Y. So the order of the points doesn't matter except for the vertex. The vertex has to be in the middle. In this case, the vertex is X, so it has to be the middle point. Also, because of the fact that this is the only angle that's associated with that vertex X, this could also be labeled as angle X. And this little symbol right here, that's the symbol for angle. And we also have this number here, so that could also be labeled as angle 3. The next thing we're going to talk about are how angles interact with the plane that they're on. Right? In this case, we have this angle right here, angle NMQ, that is on this plane. And when we're talking about how the different points that are on the plane interact with that angle, well, the first obvious one is the points that are actually on the angle. In this case, points Q, M, and N actually lie on the angle itself, and that's what we use to name that angle, right? If we're talking about the angles that are the points that are on the between the two sides, right? That would be points S and R. Those are on the interior of the angle. Those are on the inside of the angle. And if they're not on the inside of the angle, they're on the outside of the angle. That would be the exterior, and points O and P in the lighter blue shaded part of the plane are on the exterior of that angle. So the next thing that it asks us to do is to name all the angles that have B as a vertex. Okay, so we can look at the different points. So we have GBA, GBA. I'm actually going to, rather than trying to hand draw that, I'm going to use my text. So we have GBA. We have A, let me use a different color. ABD. We have ABD. We have DBE. And it's also important to notice that this also extends on out to F. So we can name that as well as DBE and DBF. And we can, the last angle that we're talking about is E or F BG. Okay. So we have EBG and FBG. Okay. And then we have the angles that are just named by their numbers. So E or FBG, this angle right here, could be angle 5. So that's angle 5. And I could use the angle symbol, but I'm just, because I'm typing it, I'm going to just write it out. I also have angle 6, which goes with DBE and DBF. And then I also have angle 7, which goes with ABD. Okay. Here it asks us to name the sides of angle 5. Angle 5, which we've already done this, but angle 5 is this angle right here. And so the sides are GB or BG, BE or BF. All three of those are the sides of angle 5. Here it says name a point that's on the exterior of angle EBD. Well, angle EBD is this angle right here, EBD. And because this ray here extends all the way out, that it also extends out through F. So F is actually also another point that's on angle EBF or EBD. I take that back. I misread that. It is not EBD. It is EDB. So that would be E to D to B. Okay, and that extends, B here extends out through G as well. Okay, so we have two angles. We have two angles that, not angles, we have 2 points that are on the exterior. Okay, this is the interior here. The red shaded here, that's all on the interior of the angle EDB. All right, the exterior ones would be this one and this one. So the exterior angles, exterior points are point A and point F. The next thing we're going to talk about are measuring angles. An angle is measured in degrees, which we get degrees by taking a complete circle and dividing it up into 360 parts. So a complete circle all the way around is 360 degrees. And the tool that we use to measure an angle is a protractor. And the important part of a protractor is this point right here in the middle, where your two baselines cross with the point that with the line that goes up through 90 degrees, which we'll find out later is actually considered a right angle. Right? So using a protractor to measure angle ABC, we take this protractor, we move it over to where this center part is exactly on the vertex, okay, and the baseline of the protractor goes out along the base or one of the sides of the angle. And when we're looking at this, we can see here that the inside ones, the inside numbers here are what start at 0. So we're going to measure it inside, and we're going to measure all the way up to where the other side is, and we can see here that it is at 60 degrees. All right. If we have an angle that is a bigger angle, we do it the same way. We put that center point right on the vertex. We rotate it around to where the base is. The baseline is right along the side of one of the angles, one of the sides of the angles, and then we look up and we follow here, which is starting at 0, follow it around, and we see here that in this case, if we look, it might not be exactly on the vertex. I guess it's pretty close to it, but it looks like it's at about 107 or 108, maybe 108 degrees. So the measure of angle MPN is 108 degrees. And the shorthand way of doing that, of saying that, is the measure with an M, and then the angle symbol, and then MPN is equal to 108. Okay. The last example I want to show you is that with measuring with the compass is that sometimes the angle opens the other direction, but the process is exactly the same. Okay, so you put the center on the vertex, okay, and you put the baseline along on the put the baseline on the one side, and you you follow, in this case, the 0 here is on the outside, and follow it around, and you see that it's at 70 degrees. Okay? The next thing that we're talking about, and let me get rid of this protractor here. Whoops. Did it backwards. Is classifying the different angles. And these are pretty familiar terms with most of you guys probably. So the thing to remember is that a right angle is exactly 90 degrees, and a right angle is shown by this little square that's right down in the vertex. All right? An acute angle is less than 90 degrees. Okay, so if this is 90 degrees here, the dotted line is 90 degrees with that, then this angle right here is less than 90 degrees. And so that's an acute angle. And then an obtuse angle, once again, if the dotted line is 90 degrees, an obtuse angle is more than 90 degrees, but less than 180 degrees. So a 180 degree angle would be a straight angle or a straight line, and it's formed by having two rays that go in opposite directions that have the same vertex. So a straight line is 180 degrees. All right, so the measure of angle ABF, very quickly, ABF is this, and you can measure it using the protractor. Okay, and flip it around, and we can see the ABF is 20 degrees, and 20 degrees is considered an acute angle. And because it is less than 20 degrees, or less than 90 degrees. Okay? What's the measure of CFE? Well, CFE would be this angle right here, CFA, okay? And we notice that CFE right here is a 90 degree angle. CFE is a 90 degree angle, and AFE is a straight line or a straight angle. So we know that CFA is 90 degrees. Oops. And the classification of CFE, because it is exactly 90 degrees, it is classified as a right angle. Okay. The measure of AFD, we see that it's going to be this angle right here, AFD. So the classification of it, we can already tell. We can tell that the classification of it is going to be an obtuse angle. All right. And the measure of AFD, if I bring this protractor over, and it is AFD starting on the outside, because the zero is on the outside, follow it all the way around, and it is looks like 115 degrees. And the last one that we're talking about is CFD. CFD, and so we just swing this around to where that lies. And I put the baseline on CF. We could have swung it the other way around, but we see that CFD is at 25 degrees, and which would make it an acute angle. So the next thing we're going to talk about are congruent angles and angle bisectors. Congruent angles, you've heard the term probably before of something being congruent, but so you probably have a basic understanding of it. Congruent angles are angles that have the same exact measure, and we can use a compass to copy an angle exactly, and we're going to do that in class. I'm not going to show you how to do it on this video, but that is a activity that we'll do in class. An angle bisector divides an angle exactly in half, and we can also use a compass to bisect an angle, which we'll do. All right, so, but it's important to know what congruent and bisector actually means, especially bisector. So in the figure below, CA and BC are opposite rays, which means that ABC is a straight line, and BH bisects EBC. So if we have EBC, and we're given that BH bisects it. Now, if you remember from that definition I just gave you, bisector means it cuts it exactly in half. All right? So it says here that EBH is 6x plus 12, and HBC is 8x minus 10. Well, EBH is this half of the angle, and HBC is the other half of the angle, and we know that they are congruent because BH bisects it. So all we have to do here is solve for x, and then put it, and then substitute it in to find the measure. So we're going to say 8x minus 10 is equal to 6x plus 12. When we go to solve these two expressions for x, you're going to draw a line down through the equal sign and subtract 6x from both sides. When we do that, we end up with 2x minus 10 is equal to 12, because the 6x minus 6x cancels out. Then we're going to add 10 to both sides. the 10s cancel out, and we end up with 2x is equal to 22. Divide both sides by 2. Twos cancel out on the left. We're left with x is equal to 11. Now it's important to notice here that that is our value of x. That is not our answer to the question that was asked, because we want to know what is the measure of angle HBE. Well, the equation or the expression for HBE or EBH is 6x plus 12. So we just have to substitute the x in to the expression, and we end up with 6 times 11 plus 12. And when we do that math, we find out that the 6 times 11 is 66 plus 12, which is 78. So the measure of EBH or HBE is 78 degrees. Okay, so that does it for this lesson. Go back, and if you haven't done so already, go back and copy all the definitions down into your notes. I'm going to be checking your notebook to make sure that you've done that, so don't try to get by without doing that, because it's important to do that. All right, talk to you later. Bye.